do on the graphing calculator. Very little of it will be done without that. Oh, you're being wise, aren't you?
No, he did it. He did it.
It was a fake yawn.
Yeah, but I still did.
I know, it's terrible. I watched a fish in a tank yawn once, and I had to yawn. A fish yawn. I swear to God, the fish yawn. I get a kick out of all these scientists. Listen, I have a degree in physics, so I know a thing or two about science. And I took AP lots of stuff when I was in high school. Science has this overinflated opinion of itself. It tends to think it's like the final source of wisdom on all questions, and it's just not. I could give you a million examples of that. First off, if you read a biology textbook from the year 1980, it's way different than a biology textbook now. So who's wrong? Were they wrong then, or were they wrong now? And don't you get the idea that a textbook in the year 2040 is going to be different than the one you're reading now? Obviously.
It's just they keep on learning new things.
Right, which means their knowledge is inadequate. But now they like to walk around saying as if they know all the answers, and they don't. And here's a great example. How many people have heard at some point in their life that a yawn is an unconscious gasp for oxygen? Okay. There is no way on God's green earth that the four of us all had a simultaneous gasp for oxygen.
Wasn't it something
Go ahead.
like a warning?
Mrs. Bing told us that it was
Like a warning.
something that humans came up with to silently signal each other that something was happening.
Okay. How did the fish come up with it?
I don't know. We came from the water.
Have you ever seen a dog do it?
Yeah.
Yeah. Have you seen a cat do it?
Yeah, but what is it?
Now they have this thing, they have a new theory that it's some kind of reflex. And the truth of the matter is that it could be a little of all. Thank you so much. It could be a little of all. It could be none of the above. Who knows? I don't think science knows. And that's the frustrating thing for me about science. Sometimes the best thing science can do is say, we're not sure. Might be this, might be that. Haven't figured it out yet, but we're working on it. So, anyway, that's my pet peeve about science. And yawning is a great proof of that. Oh my God, you're worse than me. You're worse than me.
I keep picturing someone yawning.
I got it. So you guys are going to conspire to not have a lesson one day, and it'll be like the Christmas bells. Anna will go first, Supergirl second, Nolan third, Quinn fourth, and we'll just go right around the class. And every time you yawn, I'll have to go. And then I'll get ready to teach, and someone will go, excuse, and then I'll have to go to the next way. One time I was at my mother-in-law's upstate, and
Trying to yawn now.
No,
I can see it.
I was trying
She's
not
trying
to.
to
I was trying not to.
I was at my mother-in-law's upstate. We were all sitting in the living room, and the way the furniture is, it's all kind of like a round. It's a square room, or rectangular room, but it kind of forms a perimeter. And I watched the yawn go from the person on this end of the room all the way around. Then there was a gap where two dogs were laying, and one dog yawned, then the other dog yawned. Then it got to the next one, and it went right around the room until it got to me, and I just couldn't help myself. I had to yawn. And furthermore, it was like it went from person to person to person to person to canine to canine to person to person to person. It wasn't like it went bing, 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 bing. It was just like doing the wave.
I see my
You
dog
know?
yawn all the time. That never happened for my dog.
Oh, you got to get fish then.
Oh, my fish died.
There's a
I overfed my
I
fish.
used to have fish called cichlids, and I really like them. I think they're excellent. I love them, and I don't have them anymore because we just went through a time when I couldn't have them. But we had there's a type of cichlid called a peacock, and it was looking at me. You know how fish look at you? You ever have a fish tank?
Yeah.
You know how they look at you?
Yeah.
He was looking at me, and he went. He has a sense of humor. He goes like. So what did I do? And I'm sure he laughed inside the tank. I'm sure he did. All right. So on your calculator, let's go to y equals. And I'm going to clear it.
I have a cowfish, and it's like a person, and wherever you walk, it follows you.
That's impossible.
Oh no, fish
Someone
do it all
yawned.
the time because they used to getting fed.
How would fish
And they,
Yeah, and when you have
like
the
a fish.
bowl, it's a cow. And when you have the bowl of food, they'll go crazy.
Yeah,
They'll
absolutely.
all go to it. And my sea cucumber is the only person who doesn't do that.
I used to have a saltwater tank too, and then I actually had a reef tank, which was
Oh, that's
yeah, it was.
I don't have coral yet.
Yeah, it's tricky with corals. It's much harder than with fish. I had it going really, really well for a while, and then my dad got sick, and I had to go into the hospital like 3 or 4 nights a week in the city. And I spent so much time caring for him that I couldn't care for the tank. And then the corals are so delicate, and they're so expensive
Yes.
that they just, I couldn't care for them, so I just sold it off. And I used to have all these cichlids. I had like maybe, I don't know, a lot of tanks. The nice ones, 125 gallons, 175 gallons, 120 gallons. Yeah, it was really, really, really nice. And I used to breed them to pay for the electric and the food and everything else, so it didn't even cost me money to have the fish. And then I realized I was like, it just wasn't working out, so I sold all of those to get the coral tank. And then I set the coral tank up. It was beautiful, stand, oak stand, the whole deal. It was great.
How do I zoom out?
And then, forget it. After that, after my dad got sick. So then I wound up selling all of that off, and my wife and I have discussed the idea that when we retire and we get to the next house, I might go for like a 180 gallon or a 240 gallon coral tank.
I only have 65. I've tried to buy a sea anemone. I had 2. They both died. I think it was the store though.
You know where I got my sea anemone?
Where?
And I got it for free?
The ocean?
No, Riverhead Aquarium.
The
They have
ocean.
so many of them, I went in and asked for one, and you could just cut a piece off and it grows its own.
I tried to buy a rock, but that died.
Well, it's funny because the whole environment in a saltwater tank is based on this thing called live rock.
I didn't put anything in it.
No,
Okay.
so you put something in it.
Negative 16
My rock died.
T. Well,
that
you
was
laugh,
right there. I
but
could have left it.
listen, a whole saltwater tank is based on stuff called live rock. And if you don't have live rock, you can't get a coral
I have
aquarium
live
going.
rock.
Yeah, you gotta get it. It's really expensive too. All right, negative 16 T squared, was it plus 144 T?
Yeah.
Yep.
Plus
Already got it.
144 T plus what? 160?
That was in my calculator.
Okay. Now, so the next thing that we're going to try to do is we're gonna try to graph this. So oftentimes what happens is the first time you graph it, it doesn't come out looking right. It's not that the graph is wrong, it's not that you did anything wrong, it's that the window needs to be adjusted. Now, the best way I can explain this to you is, it's like you take a photograph, okay? Are you familiar with how to crop a picture?
Yes.
Yeah.
You're gonna crop this picture. And what you wanna make sure that you do is that you get the part of the picture to be front and center and the biggest part of what you're looking at. So, the first thing I notice is I'm chopping off the top of the parabola. Can you see that? Okay,
do not have
so I need to go to a greater height.
Yeah, I don't have.
I'm gonna go to, I'm just gonna put 500 in there. And now, it's the window that's the issue. This is called the window. So I go to window. And I always like, when I'm doing a problem like this, when you're throwing a ball, because you can't have negative time, I always like to begin at -1. The reason I like to begin at -1 and not 0 is so that I'm not all the way up against the left-hand side. All right, watch it again. If I put this at 0, then this axis goes right to here, and sometimes it's a little difficult to read. So instead, I like to go to -1. And now, in this case, did you notice how my graph kind of got lost over here? So that means my x maximum needs to be further out. So I don't know what it's, I actually do know what it is, but I'm gonna pretend I don't, and I'm just gonna take a guess for now, and I'm gonna put in 12.
This looks like a swastika.
A what?
It's like an owl.
It should not,
thing.
okay. Next,
I don't know what's happening.
hey,
The Nazis are coming.
stop. On the x scale, I can go by ones, that's not a problem. Now, here we get to the problem. Well, y minimum's not a problem. For the same reason that when I throw the ball's not gonna have negative height. I like a y minimum of -1, so it gets that axis up off of the bottom of the graph a little bit. But here's the problem. The question becomes, how high is this graph gonna get? Now, you're starting at a height of 160, because the y-intercept is 160. And it's going up 144 feet per second, kind of, that's the initial upward velocity. So we're dealing with a pretty high number. So my y max, I'm just gonna make it 500. I don't know if that's good or not. But if I draw the picture and it doesn't come out good, then I can adjust accordingly. Now, the last thing is, if I'm gonna go from 0 to 500, that y scale, I'm not gonna go by ones. If I go by ones, that's insane. So in this particular problem, I wanna go by 20s, so that it all kind of fits better. Now I hit graph. And now I've cropped the picture, okay? So the graph looks good. Guys, if your picture doesn't come out looking something like this, just play with your window. Crop it. It doesn't have to look exactly like this. Yours could look a little different right now, and it's still perfectly good. Melissa, question.
There's a part and it says X-res on the calculator.
X-res?
Like RES. When you're in the window. Well, I'm on the bottom one.
Oh, I don't even use that. I wouldn't worry
Just
about it.
leave
Yeah, just leave it. Okay? Now, so here I have my graph, and this is going to approximate the trajectory of the ball. Now, the first question up there is this, or one of the first questions, is this a maximum or a minimum?
Maximum.
Maximum. And it's pretty certain, though they don't ask for the axis of symmetry, the axis of symmetry is going to run right through that point. It's also very difficult to tell exactly what that point is. Now, your calculator is able to calculate. Some people like to look at the table for the maximum value. The problem is if you look at the table with this one, you will not find the maximum or the x value, the time at which the ball or rocket or whatever it is at its maximum height. So I'm going to go to calculate, which is second and then the fourth button over there. And if you look down, one of them says maximum. So I'm going to go to maximum and enter that. Okay, is everybody there on your calculator? Okay, is everybody there? Okay. Now, here's the thing. If you read what it says here on the bottom, are you looking at me? It says left bound. Now, I call this the flashing bug. If the little bug, I want to find the maximum. Is that little bug on the right or left side of the maximum?
Right.
The right, but it's supposed to be the left bound. So I have to move that little bug over until it's on the left side. I don't care where on the left side. All right, that's good enough. It's on the left side of the maximum, and I hit enter. What's the next thing that it says?
Right bound.
Right bound. What do you think you have to do now?
Go to the right.
Go to the right side of that.
Where does it say right back?
Right here.
Guess.
Hold it. As soon as you're sure you're on the right side, hit enter again. Then it says guess. Whenever it says guess, just hit enter again. And look what they give you. X equals 4.499983. Y equals 484.
I got
You got 4.50.
99975.
Okay,
Yeah, same.
you know what? That's even better. Even better, because I got 4.49, you got 4.5. The bottom line is, this is just a slight error in the calculator. What is it really? 4.5. And that was the point I was going to make. The coordinates of that maximum point, the vertex, is 4.5 comma 484. Now the question is, how do you interpret that information? What is that telling you, 4.5 comma 484? Well, it does tell us stuff about the axis of symmetry. It tells us that the axis of symmetry is x equals 4.5. That is one of the pieces of information I can garner from that. There's more information that I can glean by looking at this. What else can you tell me, Marlena? That is the vertex, but what does the 4.5 mean? What does the 484 mean? All right, the maximum height is 484. So whatever this thing being thrown or launched or whatever it is, the maximum height it achieves is 484 feet. What about the 4.5? What does that mean?
How far it goes?
No, the 484 is how high it goes.
I know, 4.5. How far it goes when it reaches.
What? Look at the equation. In the equation, it's not x. What is it? T. Isn't that 4.5 in the x coordinate place? Which is really what? T. And what does T stand for? Time. So what it means is at the time 4.5 seconds, it's 484 feet high, and that's the maximum height. So one of the questions on your paper is, how long does it take for the object to reach its maximum height? What's the answer to that question? 4.5 seconds. So at 4.5 seconds, it achieves its maximum height. Okay? Now, we also need the 4.5 for two other questions. The first question it asks is, or one of the questions is, over what interval is this increasing? Over what interval of time is the height of the object increasing? Come on, look at the graph. No, there is no negative infinity time. So it's just from 0 to 4.5, right? I mean, I know the graph is out here, but that's irrelevant in terms of time. Now, over what interval is the object decreasing? What did you say?
4.5 to 9.
4.5 to something. I'm not sure what that something is yet. This is the something right here, agree?
Yeah.
When it gets back down and reaches the ground? Because clearly when it hits the ground, it's done. It's not going any further, and it's not decreasing any further. So now we need to figure out what this point is here. But this is called the roots, and what's another name for the roots? Zeros. So let's go to calc again. Second calc.
Can't you just multiply 4.5 by 2?
No,
Because that's.
no, because it didn't start off on the x-axis. If it had started off on the x-axis, then yes, you could do that. Does that make sense?
Yeah.
Okay, look at what number 2 says though. The zeros. So this will calculate the zeros on your graph. Now, sometimes you could just count the zeros, and I think in this case you could have counted the zeros, but sometimes it doesn't exactly go through a point. So let's do the same thing as before, left bound. Now where's my little flick? There's my little bug,
Where is it?
right here. You find it on your paper.
Are we supposed to go left bound?
Yes, I am left bound. I'm right there. Left, look at, it's left of the 0. Right, we're looking for the 0 now. We're not looking for the maximum or minimum. So I'm left bound to the 0, I hit enter. Now it says right bound, so I go to the right side, which basically means I get under the axis, and I know I'm there because I see the negative. So I hit enter. There's my guess, I hit enter again. X equals 10, y equals 0. So,
Mine won't go to 0.
Yeah, mine got an error.
why would you say error?
It said something about,
I got x equals 10, y equals 0.
That's right, x equals 10, y equals 0 is there. I don't really have the time now to go through and try to fix your calculators individually, but something hinky's going on, I'm not sure what it is. Bottom line is, x equals 10, y equals 0, and if I go back to this, it would be 4.5 to 10. Okay. All right, so that answers, I think, all of the questions on the front page. Number of seconds for the ball to reach its peak is 4.5. I don't have it, if I factor out a negative 16 from all of the terms, and that would in turn let me do the factored form stuff. I'm not concentrating on that now. What time does it hit the ground? 10 seconds. Over what domain is it increasing? 0 to 4.5, decreasing from 4.5 to 10. Using the graph, what's the maximum height of the ball? 484 feet. Okay, any questions? All right, so now what I want you to do is on the very next page, there is another one like this to do. I'm not so overly concerned that you copy the graph onto the graph paper on your second page, but I am concerned that you're able to interpret the information that you find on your calculator. So use your calculator, help you out, get going, okay? Feel free to work together, guys. A little bit of noise is a good thing.